construct a truth table for the statement M and not P implies R. We begin by creating columns for just our basic statements with no modifications to them. So that's going to be M, P, and R. And then from there, we need to construct this full statement. So I'm going to need a not P. Okay, so not P. Then I have the M column and the not P column. I need the M and not P. So M and not P. I have the M and not P, and I have the R, and so I'm ready to do my implication. M and not P implies R. So this is my my truth table. Those are the columns of my truth table. Okay, now I need to decide how many rows there are. So for that, we look at just our basic statements. We've got 3 basic statements, M, P, and R. And we take 2 raised to the number of statements. So 2 raised to the 3, which is 8. So we're going to have 8 rows here. So let's go ahead and create those 8 rows. And then we're going to look at all the possible ways to combine true and false for those 3 statements, M, P, and R. So we start by the first column. We just make half of those true and half of them false. So true, 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 4 trues and 4 falses. And then we just split, and an easy way to do it is say, well, I had 4 trues and 4 falses, so then my next column is going to go in blocks of 2. So 2 trues and 2 falses, and 2 trues and 2 falses. And my next column cuts that in half, and so 1 true and 1 false, and 1 true and 1 false, and so on. So those are the possible combinations of true and false for those 3 statements. Now we can go through and look at our modifiers. So I've got not P. That's the negation of the P column. So that just changes the truth value of each of these. So true goes to false, and false goes to true. Then we have M and not P. So looking at M and not P, that's this column and this column. It's an and statement, so we're looking for both to be true. Okay. Here, they're not both true, so this is false. Our next row, they're not both true, so this is false. The next one, they are both true, so that's true. And here, they're both true, so that is true. And the next 4, they're not both true, because we've got the falses there. So that's going to be false. Okay, and now we're ready to look at the actual conditional. M and not P implies R. So we are looking at this, okay, and this. Now remember that a conditional, the only time that it's false is if you have a true implies a false. That's the only time that this is false. So notice that in this column, I only have 2 trues here. So those are the only possible times that I could end up with a false over here. So the other ones, I'm just going to mark those are all true. Okay, if the condition, the antecedent, is false, then automatically the implication is true. Okay, now these 2, I look at what's happening. So here I have true implies true. That is a true statement. Here I have true implies false. And true implies false, that conditional is false. That means the antecedent or condition was satisfied, but the consequent was not. So there's my truth table for that implication. We almost got all trues there. And just as a side note, okay, if you get a statement that is all true, a statement that is always true is called a tautology. Okay. So, and that's going to be useful for us when we look at one application of truth tables. which is evaluating detective arguments. So this is not quite a tautology because we've got that one situation where our statement is false.